Hey everyone, my name is Jay Clark. I'm a PhD candidate based at the University of Southern Queensland. And before I get started, I'd like to acknowledge the traditional owners of the land on which I'm coming from today, the Guyabal and Jawa people, and like to pay respects to their elders, both past, present, and emerging. Now, I'm here today to talk about my poster here at the ASA, How Do Stellar Surveys Improve the Properties of Planetary Systems? So if you've seen this before, awesome. We're going to learn more about the science behind this poster. And if you haven't, awesome. Check it out after this video. So we have uncovered well over 4,000 planets orbiting stars in the night sky, and well over 6,600 planets waiting to be confirmed by ground-based observations around the world. And so we can look at these planetary systems and be able to see the transit depth and the radial velocity measurements to be able to understand the size and mass of these planets, but that is all based upon the stellar parameters. The effective temperature, the log G, the mass and radius of those stars is crucial to then better understanding the mass, radius, density, composition, and we can go further on into characterizing these worlds. What type of atmosphere would they have? What type of geology would it have? Then better characterize what worlds are really Earth-like. So that's what I've been trying to do as a part of my PhD research. And this is an amazing plot showcasing the overlap between the GALAR's latest release, GALAR DR3, and the test sectors, the Transiting Exoplanet Survey satellite, and where it's been observing. And there's a huge, beautiful overlap here. So then why not utilize the information from both TESS and GALAR? The question which I'm trying to answer as a part of my PhD project is, what can we learn about current exoplanetary systems orbiting around GALAR stars? And so what I've been able to use is I've been able to utilize GALAR's latest data release and use the effective temperature, log G, the overall metallicity, and as well as Gaia's parallax and magnitude values, two Max's magnitudes, to then use in an isochrone model to determine the mass, radius, luminosity, age, double zones of these stars, which then affect and then flow on into the planetary parameters. So what have we been able to learn? Well, I've been able to better characterize super Earths, and in particular these short period super Earths, down to a precision much better than has been previously documented, using not only these new stellar parameters, but also the NASA's Exoplanet Archive, and be able to use a weighted mean approach to better estimate the planetary properties, being your radial velocity and your transit depth measurement. So combining all of that together, for example, Corat 7b, I've been able to better characterize that well down to a precision of 3% for its radius and down to less than 8% for its mass. And so we are now at a better stage now to then characterize these worlds, what they're made out of, and continue further on with its habitability. Now, with Corat 7b, with a surface temperature of 2500 Kelvin, probably not the case. We're probably never going to find life there. But what we've also been able to discover is that it seems like ultra hot planets, regardless of whether it's a hot Jupiter or a hot Neptune or a hot terrestrial world, tend to favor iron-rich stars and also favor younger stars as well. And so here there's older stars, and down here are younger stars. And so we're seeing that the formation mechanisms for hot Jupiters and hot Neptunes and hot terrestrial worlds might be very similar, and that this process might happen as there's more material around, and less likely to happen where there's less material during younger population stars. And also what I've been able to do as part of my research is be able to determine, well, can we actually follow up these planets from the ground and be able to work out a mass measurement? And it turns out it's going to be incredibly difficult for these stars, for these planets over here. But it's going to be pretty easy to then follow up for these planets over here. So over here, going to be up here, almost impossible, but probably doable for here. So that means that it's probably going to be easier to confirm hot Jupiters and hot Jupiters around GALAR stars than it is to try and determine your smaller ones here. So that's all I have. Here's my summary for my talk. And if you want to learn more, check out my poster. Thank you so much for your time.